Hey everyone, today we're going to be working on section 6.6, which wraps up our graphing of our sinusoidal functions. So in reminder, when you are dealing with a sinusoidal function, and we'll be working on sine and cosine graphs today, the general form of the function is a times sine of omega x minus phi plus b. Now, in order to work with that to determine a phase shift, if you remember, is the shift left and right on the axis, we're going to factor out the omega term. So we take that omega term, factor it to the front. That turns this phase shift component into phi over omega, and plus b. B gives us our shift top and bottom. Now, we graphed some that had an alteration in the period in the previous section in 6.4. This section is going to alter all the things. So we'll have an alteration in the amplitude, so it's the stretching factor, an alteration in the B term, which moves our graph up or down on the axis, a phase shift, which moves it left and right, and then a change in the period as well, so the frequency at which it repeats. So cosine is the same way. Before you can use it for graphing, you do have to factor that omega term to the front. So also in reminder, the A term controls the amplitude. So remember, amplitude is a distance, so amplitude is the absolute value of A. If you have a negative, what it is a reflection of the graph, so it flips it upside down. Omega controls the period. The period T is equal to 2 pi over omega for sine and cosine. Phi over omega shifts the graph horizontally, so the phase shift is phi over omega. And if that is negative, meaning you have a positive term in here, moves to the left. If it's a negative term in here, meaning that it's just the formula, moves to the right. And B shifts the graph vertically in the same direction of the sine. So if we want to determine the phase shift from some of these, the first thing we have to do is factor out omega. So we want to factor omega to the front inside the argument. So this is y is equal to 20. If I were graphing that, my amplitude would be 20. And we have cosine. I'm going to bring the 2 to the front, and x plus 4 divided by 2 gives me 2. So here, our phi over omega is equal to negative 2, because I have a positive inside there, and we are shifting 2 units to the left. This next one, y is equal to negative 5 sine of pi over 8x minus pi over 2 plus 3. This one's a little bit more complicated to factor, so I wanted to do this as an example just so you see how to factor it out. So the first part, pi over 8, that's our omega term. X, that's the easy part because you're just pulling that forward. But then we have to factor it out of pi over 2. So remember that if you're factoring it, we're pulling it to the bottom. So I have on the side pi over 2 divided by pi over 8. We're going to hold the top one steady, flip the bottom, and multiply. Pi's cancel out. 2 cancels into the 8 and leaves me with 4. And we're adding 3 to the end. So here, if we were going to work on the phase shift, that phi over omega for our phase shift is equal to 4. Remember, it's like the opposite sign of what's in there because the sign itself in the formula is negative. So we are going 4 units to the right. Now, when we're going to graph a sinusoidal function, we do it in a series of steps. So the steps here, and this is a nice thing to print out, and as you go and practice this graphing, you'll have it in front of you. So the steps are, we find the midline. That is our shift top and bottom for our graph. So y is equal to b is our midline, and we'll plot that. And then we are going to find the amplitude, and the amplitude we can count from that midline. So if the amplitude is 5, starting from the midline, we have to go 5 units up and 5 units down. Then we find our period, 2 pi over omega. The distance between the key points in the primary period are the period, whatever the period is, divided by 4, because we have 4 points in that primary period. We'll find our reference point, or where we start the graph, and that's based on our phase shift, and then we will plot the key points. So here, let's start with 3 f of x is equal to 3 cosine x plus pi. So if we go in order, this one does not have something added or subtracted on the end, so really it's like plus 0 here. So midline, y is equal to 0, or just our x-axis. So I'm going to plot that in just because I want to know, I want you to be able to see that we actually took that into account. So here is our midline, y is equal to 0. So part 2, remember that we're following the set of steps. So part 2 has to do with our amplitude. So our amplitude here is 3. So whatever your midline is, then we are going to go up and down our amplitude, because that's the height that your graph will achieve. So this one's going to go to 3 and -3. All right, next we're going to find our period. So our period here is t. So t is equal to 2 pi over omega. This one, omega, is understood as 1, so 2 pi over 1 gives me 2 pi. Part 4, we need to know where to put the tick marks on the axis. So we're going to take whatever we got in part 3 and divide it by 4. So our axis marks are 2 pi divided by 4, or pi over 2. So I'm going to put those in, and we're going to move and put our pi over 2's on our graph. So pi over 2, 2 pi over 2 gives me pi, 3 pi over 2, 4 pi over 2 gives me 2 pi. We're going to give ourselves some in the negative direction as well. Okay, we're dealing with the cosine graph. So remember, when we are dealing with cosine, that's the one that starts high, goes down, comes back to the top. So this is our basic look of cosine. Now we have to ask ourselves about the phase shift. So part 5 is that phi over omega. Looking at this, there was a 1 for me to factor out, so we didn't really have to factor anything, which means that my phi over omega is this component here. Now it's positive, and remember the formula is negative, so we have negative pi, or we're shifting pi units to the left. Now what that does, that phase shift, it makes like a faux y-axis. So instead of starting here at the y-axis, the entire graph is pushed to the left pi units. Now it's going to look the same, so we're going to start at negative pi, and we're going to make the same shape of the cosine, but it doesn't start at the x is equal to 0 line anymore. Okay, so last part is plotting in our key points. So we're starting, cosine starts at the top, so here is the first point, and we're moving pi over 2 units to the next point. So here's the next point in our primary period. Then we go to the bottom of the graph, top, and then we're starting the second period, and so on. if we were to continue in the other direction, remember these functions are continuous, so while we use the phase shift to plot our primary period, it doesn't actually stop at that point. We just use it to place it on the graph. So here is a graph of our function, 3 cosine x plus pi, and it looks like this. All right, moving on to something a little bit more complex. We are wanting to sketch a graph of the function g of x is equal to 4 sine pi x plus 2 plus 1. Now this time I have an omega term that is not 1. So the first thing I'm going to do before I even start with my steps is factor that pi to the front. So g of x is equal to 4 sine and pi times x plus 2 over pi plus 1. Okay, so that would factor together, back together into our original, so that's what we want it to do. All right, so now let's start with our steps. So our first one is we are looking at our shift up and down. So y is equal to 1 because we're adding 1 onto our function. And I'm going to make a 1 hash mark here. So here's 1. And then I'm going to plot that in. All right, y is equal to 1. So when we graph our actual graph, this is going to be our axis that we're working on. So when it comes back to what would normally be 0, it's going to come back to this line instead. Okay, so our next part is our amplitude. And our amplitude is 4. So we are going up and down 4 units here. So 2, 3, 4, and 5, that's what we get to. 0, -1, -2, -3 is where we go in the bottom. All right, next part is our period. And we have 2 pi divided by omega. Omega here is pi. So our period is equal to 2. Now normally we see the period with sinusoidal functions in some unit of pi, but it does not have to be that way, so this one has a period of 2. Where we're going to put our marks on the axis, so if we are dealing with 2, that means our hash marks are going to be 2 divided by 4, or every 1/2. So I'm going to put some of those out there, and we have 1/2, 1, 3/2, 2, 5/2, 3. Moving in the other direction, -1/2, -1, -3/2, -2, -5/2, and -3. All right, our phase shift. So phase shift, phi over omega, is negative because we have a positive sign in here, so we're moving -2 over pi units. Now, 2 over pi is not something that I can think about in my head and just get an approximation for. So, so I am going to do that arithmetic in my calculator and get an estimation. So it says, according to my calculator, to 2 decimal places, it's approximately -0.64. So a little more than a half. Now that's important because that's where it gives us our starting place, our axis. So we are, if I plot that in, we're starting this thing negative a little bit more than a half. Now this point right here where these 2 dashed lines meet, that's our new origin. And we're dealing with the sine function. So the sine function, the basic one, starts at the origin, goes like this. So this is the graph that we're dealing with. So when I go to plot this, we'll do purple. This is my origin. My next point goes up to the high point on the graph. Now, the high point is going to hit the 5, but I'm moving over a half. Remember, your 4 points of your primary period are 1/2 apart. Now, I'm not nicely on the -1/2 line, so I'm not going to land nicely on the 0 line either. So here is my next point. Next one brings us back down to the axis. And next one brings us to -3. Back to the axis, back to the top point, and we'll bring it back to the axis to give us 2 periods. So this one's pretty steep and looks something like this. No, we're not quite 2 periods, but you get the idea. All right, reach out to me if you have any questions, and good luck on this section. Thanks.